Hello, everyone. How many of you get a little tense when someone says the word math? Maybe your shoulders tighten, maybe your stomach flips, or you find yourself counting down the minutes until class ends. That reaction is normal and it has a name: math anxiety. Today, I'll explain why many people find mathematics difficult, what mindset supports real learning in math, and practical approaches that help students stay motivated. I've worked through all of these challenges myself and reviewed research and teachings to put together strategies that will actually help students improve. First, I'm going to explain why mathematics is often perceived as hard. Second, I'm going to describe the mindset that supports real learning in math. And third, I'll outline concrete approaches for staying motivated and making real progress. With that mental map in mind, let us begin by looking at why math is commonly perceived as hard. Mathematics is often labeled as hard because it asks learners to think in abstract, cumulative, and precise ways. As Marissa Longoban explains in What Makes Mathematics Difficult as a Subject for Most Higher Education Students, 2020, math requires abstract thinking, logical reasoning, and problem solving skills that are not always emphasized in early education. This means that a student who misses a foundational idea in early on can struggle later because math builds on itself. To make this concrete, in many other subjects, you can memorize a fact and use it once. In math, a single missing concept can block your understanding of many later topics. Not only that, but mathematical notation compresses ideas into symbols that must be decoded. These three features, abstraction, cumulative structure, and symbolic language, combine to create a steep learning curve for many students. In short, math's abstract nature and cumulative structure are major reasons students struggle. Now that we know why math is commonly perceived as hard, let us look at the mindset that helps students overcome these issues and obstacles. For learning mathematics, a growth mindset is crucial for understanding and applying concepts. K.L. Sun, in The Role of Mathematics Teaching and Fostering Growth Mindset 2018, reports that students who believe their mathematical ability can grow with effort are more likely to persevere and achieve deeper understanding. Carol Dweck's work in Mindset: The New Psychology of Success, 2006, makes the same argument. People with a growth mindset interpret challenges as opportunities to learn, while those with fixed mindsets see difficulty as evidence of limited ability. Practically, a growth mindset changes how you respond to mistakes. Instead of thinking, I'm just not a math person, you ask, what does this mistake tell me about what I don't yet understand? That shift, treating errors as information rather than proof of failure, makes it possible to target gaps and improve. It also reduces fear that often prevents students from trying harder, more complex problems or even asking for help. Believing that ability can grow with effort changes how students respond to difficulty and increases persistence. With the right mindset in place, let's move to specific strategies that keep motivation high and learning steady. There are several practical habits that make learning more effective and less stressful. First, break problems into manageable steps and achievable goals so progress is visible. Small wins will build confidence. Second, practice. Work through problems, explain solutions aloud, and test yourself instead of only rereading notes. Actively practicing strengthens retrieval of problem solving skills. Third, reframe mistakes as learning opportunities. As Sun notes in her 2018 article, when students are more encouraged to see mistakes as opportunities for learning, they are more likely to stay motivated and persist through mathematical challenges. That means when you get a problem wrong, write down exactly where you got stuck. Then try to explain the error in one sentence. Finally, practice similar problems until the concept clicks. Other effective practices include space practice, seeking timely feedback from instructors or peers, and using worked examples to model problem solving steps. Joining a study group or teaching a concept to a classmate also reinforces understanding and builds confidence. Over time, these habits will replace uncertainty with predictable, repeatable steps, which reduces anxiety. Small goals, active practice, and refraining mistakes all supports motivation and steady improvement. In conclusion, mathematics is often experienced as difficult because it is abstract and cumulative, because its symbolic language can be a barrier. Marissa Longoban's 2020 analysis highlights these structural challenges. A growth mindset, as described by K.L. Sun in 2018 and Carol Buick in 2006, changes how students respond to difficulty and increases persistence. Practical approaches such as breaking tasks into steps, practicing actively, seeking feedback, and viewing mistakes as learning opportunities help students stay motivated and make real progress. If the word math makes you tense, remember this: math is not a test of who you are, it is a process you can learn from. With the right mindset and steady habits, the puzzle becomes solvable, one step at a time. Thank you, everyone. Here is the citation work for all of the sources used throughout this informational speech. Thank you. Goodbye.